When most of us are learning to code, we tend to compile lots of files and folders containing all of the code we've been learning, etc. I've just gone back through mine recently and discovered I think literally hundreds of files of different OOP techniques, NumPy, pandas, etc. And I can go through it, I can see all the comments I've put in. And one, I can see kind of how bad I was back then. And two, it's nice to see kind of how much I've developed and gotten better as a programmer. Now, it's a good thing I kept all of these files because going back through them gave me a really interesting idea. And that idea is that we don't just learn once from learning a technique. If you keep hold of that file, we can actually learn twice by kind of revisiting it and applying a couple of different techniques to these files. And what I want to try and do in this video is outline these 6 ideas. And I think if you had a go at doing these 6 things and kind of going back through your old code, iterating through, it's a really good exercise in things like code review, optimization, linting, testing, etc. So this video is going to be talking about 6 things I think you should do if you've got loads of old code. If you can go back and do these things through it, I think it's a great way to make you better as a developer. The way this is going to work is I want to spend like a minute or less on each of these 6 ideas, and then the latter half of the video will be going through some of my old code for the first time and exploring these ideas and showing how you can actually put these into practice. So just to reiterate, if you've got old code, have a go at doing these 6 things and see if you can benefit in any way from it. If you benefit even just like a bit from doing this is a great exercise. And of course, the more old code you have, and ideally like the worse that code is, the better these 6 things become. Number 1 is refactoring. Refactoring is simply when you take some existing code, maybe it's been written a bit kind of crazily and it's really long and faffy and you've got a million things in one function, and trying to make it like easy to read, easy to understand, and just make it so that the code makes much more sense. You can tend to do this quite a lot in the industry. You take some old code that's written in kind of a silly way and you just make it more concise, clear, split it off into like appropriate functions and methods, maybe apply some comments to it, and just make it so that it's a better experience for everyone involved. Number 2 is doing a mock code review. Now, I think this applies more to those who are kind of wanting to go into the industry. If you're wanting to work as a software engineer, one of the things you're going to be expecting to do is a code review. So somebody's going to say, here's a merge request I've done, or here's a brand new batch of code. Can you go ahead and just review it for me? So what you'll do is kind of be a fresh set of eyes looking at this code and trying to spot any really obvious issues or any way which you think this code might break. So ideally, if your code is really old, like I'm talking like years old, this can be a really nice way of doing it, because even though you wrote it, you might have wrote it so long ago where you looking at it again is like a fresh set of eyes on it. Number 3 is optimization, and these are ways upon which the performance of your code could be improved. A really good example for this is I went back from my old solution to the 2-sum leap code problem, and my initial way of doing it is using like nested for loops. But of course, because you're doing a nested for loop over like one sequence, the longer that sequence got, like the crazier this become, like it was like exponential time or whatever. But actually, if you use a dictionary in a smart way, it becomes a whole lot better. So I went back to my original solution from many, many years ago, kind of rewrote it using a dictionary, and it's now running in linear time. So my advice for this would be look at things like unnecessary for loops. Are you doing a loop that's running for too long where perhaps it could be breaking earlier? Are you using libraries which have better versions available? Basically, you're looking for any way upon which your code could run faster, but the current code doesn't do that. So you're basically trying to swap out a bad part of the code for a part which you think could be made a lot better. Number 4 is type hints. I've done a previous video on this, so make sure you check that out on the channel. Loads of my old codes just simply didn't bother with things like type hints or docstrings. So going back and maybe importing the typing module, maybe running MyPy through your code, it just makes your code that much better, like straight away. Code that doesn't have any type hints, annotations, or any docstrings at all is pretty garbage. So simply going back and adding your type hints, adding your docstrings makes that code better straight away with arguably not much effort. Number 5 on the list is linting. And if you go back through the channel, there is a video on like the rough formatter in linter, which is really good. And one nice improvement you can make is simply running the rough linter formatter through your old code and just seeing what it comes up with. Guaranteed, if your old code is perhaps of not the best quality, rough will pick up something about your code which you can then go and improve. So this kind of links back a little bit to point two on code review. Generally, if you're doing code revision work, you're using a linter as well. So kind of going through the linter, seeing what it says has to be improved, implementing it, rerunning the linter until eventually there's no errors, is a really nice kind of quick way to improve on that code quality. And lastly, which is a bit of a different take, is trying to write unit tests for your existing code. And one interesting thing I found doing this is a lot of my old functions were kind of so big and so archaic, it was almost impossible to write unit tests for them. I mean, yeah, you could write the tests, but the tests just became absolutely mental. You know, if you follow the single responsibility principle, your function should be doing one thing well. Those functions that you write to that principle become really easy to unit test for. So for this one, I wrote writing tests and refactor accordingly, because you might find that your old functions and methods are so big, you decide to split them out. So this kind of goes back to number one, refactoring. You might choose to kind of rewrite the functions in little bits, therefore making the unit tests easier. So just to recap, we've got refactoring, code reviews, optimization, type hints, linting, and unit tests. So let's flick over to VS Code. We'll take a look at some of this rather interesting old code, and we'll apply these techniques now to show you what this looks like in practice.
And here's the first bit of code we're going to do our review on. Now, this took me a little while to figure out kind of what I was trying to do here in the first place. And the fact that I can see that I'm inheriting from objects means that either I did this back in Python 2 when this was kind of required to inherit from the base, or I was doing it in Python 3 and didn't realize that I didn't have to do this. But yeah, anyway, this class is basically here to represent things on like a high ropes course. So each item had like a name, how old it was in years, a difficulty, and then if it was in use or not. So let's see what we've got. We've got a class, we've got a constructor, we've got a print statement here. That's pretty gnarly, isn't it? We have this big str here, just so this works for being printed. That's cool, yeah, we're going to be changing that. And looks like we have a method to update an element's age by 1. What do we have here? We have two different variables. We have two different instances of this class. One where I've passed in false, so false must apply to this in use here. Why would I pass in false? Even though it's set to false. Okay, anyway, yeah. There's loads of things here which we could be making a lot better. So the first thing I want to do is just quickly show you this. This is my rough toml here. Let's run rough through this and see what rough thinks. So if I do rough, we'll do class, let's see, testing.py. Ooh, look at this. Notice how there's lots of D's here as well. Those D's correspond to PyDoc style, and I can't see any more, but yeah, there you go, there's one. Yeah, there's none at the top here. Because I've got the rough extension as well. You can see, like, if I hover over this, missing docstring in public module. We've got use fstring here, yeah, fair enough. Missing docstring, I bet, yeah. One there as well. And this here. This doesn't need to be comparing to true, we can just do if this. Okay, so lots of things to improve. I think first things we should do is work on the documentation strings and the type hints. So I'm going to speed this up a little bit. I'm going to go through and write all the doc strings. We'll rerun the linter, see if it's happy, and then we'll kind of move forward from there. Okay, there's my documentation strings done here. Now, sometimes it sort of depends on what I'm doing with init here. Sometimes I provide like the full kind of context of what is name, what is age, what is difficulty, etc. In this case here, I don't think it's super necessary. I tend to kind of put these in if they're really archaic or if they're really complicated. But in this case, we're just passing in various things and put them in here. There's only going to be 4 of them, and with one being a default. So I don't see a huge need to do that in this case. Let's run rough again. So previously I had 9 errors, down to 5. Looks good. What are we missing? Missing docstring in public class. You know why? Because I've been really silly and I've done this here. That should be like that, with an extra one here, but quantity back at 0. Let's see. One blank line required of docstring here. I quite like how pedantic rough is actually in this case. Okay, I think that should be happy, so we should see this be narrowed down again to 4. And there is nothing else in like the docstring arena. Now, let's do some type hints. So let's see what we've got here. So name, I want that to be a string. Age, I want that to be an integer. Let's see, yeah, difficulty. Oh, goodness, I think that's a string, yeah. Hard or hard, okay. Let's do difficulty. set this guy to a string, and then when you've got a default one, you can just do in use boolean like this, and that should be fine. We'll rerun the code again, make sure it's happy. It is. We'll rerun rough. We've not introduced any errors, which is good. So I now need to do them down here as well. So this takes in nothing. In fact, even this guy, we can do give back none. Let's see, that's going to be too long. Okay, we can sort that out in just a second. This guy here, str, this is going to be given back a string. That's fine. This age element, this gives back nothing either. So we can say this guy also gives back none. Okay, we'll rerun this. I know we've just introduced that one. Now what we can do, let's try and do a rough format here. If I do rough format, okay, that should have reformatted it. And this here, there we go. Kind of cool how rough does that. So now that's been sorted out. So let's rerun the rough formatter, or rough linter I should say. Now we're still on 4 errors, which is good. So let's kind of go through these from top to bottom. Class element inherits from object. Yeah, don't do this. We used to have to kind of back in the olden days. Nowadays, whenever you create a new custom class, those methods from the base object are already there, so you don't need to worry about doing that. You would see that in like the Python 2 days, but now, yeah, it doesn't really matter. Let's try that again. Okay, our next one is on line 18. Now, what have we got here? New element initialized. I mean, I don't think we even need this. I think I was just kind of trigger happy when I was writing this, so if wanting to do prints everywhere, but yeah, I don't think we need that. Comparison to true should call cond is true. Okay, yeah, really common mistake, and to be honest, one I see quite a lot in beginners here. So what we're saying is, if self.inUse is equal to true, but actually, if you just did it like this here, if self.inUse, whatever the kind of Boolean value of this is, it's basically the same thing. So if you just did this, if self.inUse, so self.inUse is going to be defined up here, passed in as false, you know, so in this case, it'll just be if false, then yeah, go ahead and do this guy instead. However, I do want to kind of rejig all of this. This is not very optimal in my opinion. So let's just run it again. Okay, we're now down to 1 on line 33. Use an F string instead of format. Yeah, this can go, can't it? So for this case here, what we'll do is take self.age. I mean, format strings are good, definitely have their place. But for simple ones like this, just think that looks better. I don't know about you guys, but I prefer these. And it's clear. Rerun that again. Okay, we've got a few warnings. One of them, it looks like it's telling me off for using rough wrong, which is quite funny. To be honest, I very kind of rarely use rough to check like a single file like this. It's normally on kind of whole packages. Okay, let's see what have I got here. So I've got these 2 things saying these are incompatible. Ah, okay, interesting. So I think what this is here, this looks like it's a fault of the, what's D? The D is PyDoc style. So see this ignore section for your rough toml? If I go ahead and do, just try D203, try and run that again. Okay, yeah, so it's like incompatible rulings basically. So let's tell it to ignore D212. Save that, rerun rough. Okay, I think we're good. So rough check, nothing. Right, cool, that looks good. Right, let's head back to here for a second. Now, we've done our type-ins, we've done our doc strings, we've done kind of our initial sweep over and our little kind of code review. Now let's think about how this can actually be made better. Now, the first thing that would kind of come to mind when looking at this is I don't think this is optimal. We've basically got 1, 2, 3, 4, 5, 6, 7, 8 lines just to make a print statement happen. Not very good. So what I'd probably be inclined to do is to make this into like one big F string and then replace this with a conditional inside the F string itself. So let's speed this up a little bit. We'll get this bit done first, and then we'll then worry about this in a separate bit. Okay, that's a good start. Now let's remove this here, and now what we can do is just return this F string. What's that complaining about? I think that was complaining about the space. Yeah, that's okay. Okay, to handle this bit, so let's see what this is doing. This was saying if self.inUse, then basically kind of append this onto the end here. What we could do, I think, is probably use a ternary. So if we just do something like suffix, so ternary is always kind of like do this if condition, else this. So we want to basically do blank n. Let's just do, no, we'll do it exactly the same as it was. We'll do this, element in use, if it's going to be the same condition. So this is going to be the string we have if this is the case. Else, an empty string. Let's see, that's complaining about line length probably. Yeah, that's okay for now. You can take that. Let's do clear. Let's run. Okay, so this one, the shroud has it as false, so that's okay. That shouldn't show, which is good. Let's try this. Okay, cool, that looks good. Now we just need to run, let's do the formatter. So come back to here a second. Rather than doing rough check, we will do rough formatter. Rough should format this now nicely. Right, okay, clear. And let's try and do rough check again. So I quite like to do this kind of as I'm coding through. It just kind of keeps it consistent. You don't be running this right at the end and find like 10 different errors. And for an initial review, I'm quite happy with that. There's not a huge amount to optimize. There's no kind of loops. There's no kind of iteration over something we can improve on. Let's see. So we have a nice kind of initialization method. We have this here. Does this warrant being a class attribute? Let's see. Element quantity. I'm not even using it. So if I'm not using it, I'd be kind of inclined just to get rid of it, to be honest. You know, the last thing you want is have just tons of pointless kind of variables hanging around. Again, we'll run the check, make sure it's happy. And then we'll run the code again, make sure that's happy. Yeah, that looks fine. Self.age plus 1, do I really need to be printing this? I would be asking the people using this code if this is relevant. If not, I'd be getting rid of it. Let's see. The namings of things. Nope, we don't want a capital letter there. We want to keep a bit of a bugbear, that having variable names like that. Let's see, what else have we got? Class element. Maybe that's not the best. Let's maybe do ropes course element. And then we can take this here, because we know how to pass these in differently. Okay, I think that looks okay. What I might be inclined to do, just kind of break off like the class from like the creation, is just kind of stick in one of these here. So if name is equal to main, and go ahead and make all the stuff. I want to complain about anything now. Shouldn't do. How about the rough checker? No, that's fine as well. Okay, let's have a go at writing some unit tests for this. It's really simple, this one. I think in terms of like what they're doing, like this is doing a single job. I mean, I guess the print you could argue is two, but I think in terms of what it's doing to the instances, this is a single thing here. And we can also write tests for this. We can also write tests to make sure that these attributes are kind of set appropriately as well. So to do this, let's come back to this level here. You can see how many OOP stuff I used to have. This is just one folder. I used to have like, I've got this whole OOP one as well. Kind of a lot of questionable code. So let's write test classes .py. Let's go into here and let's write unit tests. No, come on, you can write better than that. We'll do unit tests for ropes course elements. Now, that extension's quite good. You can see like, oh, that straight away it's kind of told me off. Okay, so what I want to do from class testing, I want to import ropes course element. Okay, so that's going to complain about it not being used. Now let's write a test just to make sure that all of this can be set up. So let's just call this one test instance setup here. This is going to return none because we're going to be using assertions inside it. And let's just do test that the attributes are set correctly. Okay, now what are you complaining about here? Empty lines? Probably? Yeah, it looks like it. Okay, so let's just call my instance. Let's do ropes course element here. Doesn't matter what the name is. I'm just going to do A1 easy. Leave it as false. That's fine for now. And then we can just do a couple of assertions. Now we can do a couple of assertions, and we'll do assert instance.name. Now this might seem really trivial, just having tests to check for like, is the name equal to A, even though we passed it in here? Well, of course it is, and we can see it. But the whole kind of point of unit tests is to it's almost like you're playing the long game. You know, if you're working on this code, it's going to be in use for a couple of years. Just having like a fail-safe piece of logic that just checks, okay, is the class being set up exactly as we intend to every single time? And this could run on like, you know, a push to Git or whatever. It doesn't really matter really. So let's do one. Let's do easy. And I think we had one for, let's do assert. We'll do not instance.inUse because it's set to false. And then we can run pytest. Should pick up, yeah, because you could have done like test underscore. Okay, one test passed. So let me just kind of show you like what would happen. Suppose somebody came along one day and just made this to true. There we go. So that's kind of picked up that this is wrong here. Where true is equal to in use, and it's basically picked up that this is not what it was expecting. You know, you can even do things like I don't know, this should be false. You know, things like that would work as well. So if I did this again, this should be false. Obviously, it's clearly not in this case. Let's see. Let's set this back to false, shall we? And should be good to go. Okay, so we got one test. That looks good. Now then, let's go ahead and test. I'm always quite inclined to test from like top to bottom. So we'll do str here. Now, what you could do, because we're kind of using like this a couple of different times, you can like make this a fixture. But in this case, because I'm just doing it like twice, it might just be easy enough to kind of like define it outside. So actually what you could do is do like this here. And pytest should be happy enough using that from there. It is, yeah. I'm just quickly change one thing, make sure it's still kind of fully working. It is, yeah. So in like much bigger programs, suppose you had like 10, 15 different tests, whatever, you can make this into like a pytest fixture, pass it in, you can have multiple different fixtures for etc. But in this case, it's fine. We've only got kind of 3 tests we need to make. Let's do test print format. In this case, let's do none. Let me spell it right. And what we're looking for here, we are looking for, let's say test that the print method, or str, works as we expect. Okay, now what I want to do for this one is probably just go back here and kind of take this like that. Okay, so what I'm going to do is just kind of pinch this here and just kind of comment out for a second. So think of it as like, this is a snapshot of what I want the print to actually look like. What I can do is kind of take this and let's just make sure these are kind of fixed in time. So self.name, we want to make sure that is A. Age, we did that as 1, didn't we? So I can go up to 1 here. Difficulty is easy. And there was no suffix for this one. Okay. So let's do this like, I can probably do it in one line actually. If we did assert instance.dunder str is equal to this. Now, will we get it right first time? We did. Ooh. Okay, just make a change, make sure that is actually working. Yeah, there we go. Okay, and to be honest, that's fine for now, I think. I think if this was like a much more comprehensive version, I'd be passing in a few different instances of these with different types of things and just making sure that it actually like works correctly. What I might do as well is check that, let's see, that this bit works as well. So what I'll probably do for this is just make a separate one to do, let's call test print format, and we'll do none here. And then we'll do a copy of this. Works as we expect with ternary. Okay, so this is now doing that's doing that ternary bit at the end. Now I need to get rid of this, don't I, first? Yeah, there you go. Nothing wrong with that. And then what I might want to do here is do instance dot in use equal to true. So set this guy equal to true here for now. And then what we can do is then basically pinch this again. Okay, and then what I'm going to do is now come back to here and do Let's see. So expecting element in use to appear at the end. So what I might be inclined to do is take this and put this here. Now, will it work first time? It does. Let's take this, move this here. Cool. Looks good. Now, I suppose in some cases you might be able to do these both together in the same one. But I really just enjoy the idea of like your functions and tests kind of being like, this is testing specifically for this. This is testing for a specific other use case. Just because, like, you know, suppose we looked at both cases in this one fails and not the other, just makes it kind of more of a pain in the ass to debug. So in this case, I'd say that's pretty good up to there. We've only got one more left, which is age element, and then we'll call it a day there. So let's do test age element. Okay, and this is going to be, again, this is going to be returning none. And we are testing that the age, incremental age method works. Okay, so what did we define at the start? Defined at 1, didn't we? So this is going to be super easy. Let's assert that it's equal to 1 first. Let's do age is equal to 1. Then we'll do instance dots. Where is it? Oh dear, what's it called? Age element. Not the greatest. But yeah, okay. At least we can see our little things appearing now. And then we want to then make sure that it's 2. Okay, it looks good. Suppose someone came along here and changed this method and they weren't allowed to. Yeah, there we go. So what I probably want to do here is do a little message just to say like, oh, what should this be? There you go, kind of a little note to myself here. Is the incrementing by +1? So it should be. This should be 2, and current age is 3. Yeah, so we don't want that. Okay, so let's come back to this here. Do this like that. Probably test classes. Okay, we have 4 tests all passed. So guys, we'll wrap it up there. I'm going to remove this print statement for a minute. But all I really did here was kind of spend, I don't know, 50 minutes or so just going through some old code, and I've learned kind of some new techniques again. So basically I learned things like type ints and proper doc strings kind of later on in my programming career. But I've now had a second chance to go through and apply it to like an old, and I guess, more difficult situation. So if you're kind of going into the industry, you're often going to be working with a lot of older legacy code that maybe isn't up to your kind of current standard. So going through it like I've just done here, it's a nice chance to refactor, optimize, write a load of tests. So that's some good practice there. We've been able to use things like f strings instead of format strings. We're able to use a nice ternary rather than a kind of clunky if-else statement, and just have a go at kind of rethinking our logic from the first place. So guys, if you have any more suggestions as to how perhaps you think you could improve on your old code or things you do, I'd be really keen to hear them. Cheers for watching guys, and see you all in the next video.